Okay, this is our last video for week 10. And these videos, we're going to be talking about iteration. So first, we're going to walk through for loops, and then we're going to walk through map functions. And this is going to set us up for in class to apply and practice sort of the power of these functions. But to start us off, we're going to be using both the IRIS and the mtcars data sets. So as a reminder, these are data sets that are built into R. You don't have to load them in, but you can just call upon them. So if we use the head function to look at IRIS, we can remind ourselves that IRIS has 4 columns of different IRIS data and then different species. And mtcars, if we use the head function to look at that, has a bunch of car data. And we'll note that it has cars in what kind of looks like its first column, but you'll notice that this doesn't actually have a column name. And what's happening in the mtcars data set is that the row names are actually the car names, which is not a convention I normally support, but it will sort of matter on how we work with the mtcars data set in a little bit. Okay, and I want to remind us that kind of all the way back to week 1 and 2, we talked a little bit about how to subset with square brackets, which since then we sort of transitioned to mostly subsetting with the $sign. So we'll call in a data frame, $sign, column name, but we can also remember call in a data frame, use square brackets and specify which column number we want. And sometimes we can also specify which column or rather which row we want. So if, for instance, we just say iris open square brackets 1, what the output of this is just the first column, but in list form. If we do iris and then a double square brackets with 1 inside of it, the output of this is still the first column, but in a vector form. And so remember what we normally do these days is we do iris $sign, and then we'll do sepal length, which is our first column. And so you can see how those outputs are similar. But as we're saying, if we do, I'll say in a second, another way of doing this is iris open square bracket. And then because iris is a data frame, it has 2 dimensions. We can specify the dimensions with a column in the middle. So open bracket, and then anything on the left of the comma is a row, anything on the right of the comma is a column. So if you do iris square bracket comma 1, once again, you're still just getting the first column for all of the rows because you didn't specify anything. If you do iris square bracket 1 comma 1, you get only the value of the first row and the first column. But also if you do iris and then we go back to our $sign sepal length. So we have iris first column, but then use a square bracket and say 1. What this is calling upon now is the row because you've already called upon the column. So now this single bracket after the $sign is still going to call upon the first value in whichever column you've specified. So all of these things are pretty useful to kind of know when we're running through for loops. So like I laid out in class kind of quickly at the end of last week, is that there is a layout of this concept of a for loop. And what a for loop does is it takes an indexed value, usually referred to as I, and for every value of I kind of runs a series or whatever operation lives inside the curly brackets of a for loop. So the layout of for loops is that you will start with the word for, open up parentheses, and then assign a value of I, which is your indexed value, although you can name this A, X, whatever you want, but we'll generally call it I. So for I and then in, and then you specify a range over which you want to iterate. So in this case, I want to take 1 through 10. And then what I want to do through 1 through 10, I'm going to specify inside the curly brackets after I close out my parentheses. And for now, what I want to do is for the value I, 1 through 10, I'm just going to print out I so we can see what I actually stands for. And what gets printed out are the values 1 through 10. And you'll also maybe notice that in our global environment, I now has a populated value. And if you run that value, it's just 10. And why I equals 10 in this case is that's a good signal to say the for loop has said, okay, when I equals 1, print 1. When I equals 2, print 2. And the last value of I is 10. And so what R stores is that last value of 10 as I. Rarely do you want to just print numbers, but we can start thinking about indexing by saying, again, still for I in this range of 1 through 10, let's say I want to print the first 10 rows of the sepal length column. So we can say inside these curly brackets, I want to print iris $ sepal length, and then use this square bracket after the $ subsetting method. And so you can think of I will always have a different numeric value, and that will print out then the different rows. So for I in 1 through 10, print out the first 10 rows of sepal length. And you can see in the console, you get 10 values. They are likely what we expect them to be, but we can say, let's look at the head of iris $ sepal length, n equals 10. And these are exactly the same in slightly different data forms. But the power of the for loop is really that you can do a lot of things at once in the for loop. So what we have done so far is really could be done outside of a for loop, but you can merge different kinds of data. You could do really complex functions inside of for loops. And so just to demonstrate that, it doesn't have to be just one line of code, and it can be many. And so you can say for I in 1 through 10, and then inside your curly brackets, really create an entire new sequence of code where you don't need commas. All you do is if you close out a line of code like we have, if you say print iris $ sepal length with an I index, that will do what we had just done, but you can space down. And then let's say we want to print the value of cars $ mile per gallon and every row, that we can put that on the space below. And when we run this for loop, what we get as the output are the values that we know to be now sort of the first 10 rows of iris, but it's interspersed with what we can imagine are the first 10 values of MT cars miles per gallon. And they're in this order, which is a good way to remind you that to think of it as a loop is that this is the value of iris sepal length row 1 and the value of MT cars mile per gallon row 1. Then these two values for row 2, these two values for row 3. And so it will run through every line of code with each value of I, not sort of 1 through 10 for iris and then 1 through 10 for MT cars. It's also important to note when you're running for loops to pay attention to your cursor placement, because let's say, for instance, I put my cursor at the end of print, just this miles per gallon line of code, and run it. I get a single value, which is 19.2. And what's happening here is that from previous loops, remember I said I is specified as the maximum value of 10 right now. And when I just run the line of code that says print MT cars $ miles per gallon bracket I, but the value of I right now stores the value 10, what this gives me is the 10th row of the MT cars miles per gallon. So make sure that your cursor is either at the end of the curly brackets to get the entire output, or that you highlight the entire for loop and run it. But let's say that we want to actually store the output of our for loop, which we also talked a little bit about last week. And storing the output is something that I think really prompts you to take a step back and think about, what am I putting in to a for loop or any iterative function? And what do I want out? Because I think probably the default for most iteration is the output of a list, which we don't work very much with in this class. And you may not work with very much in your own research. And so specifying what the output is that you want is really going to help you kind of get the dimensions of your data right. So let's say we're going to work through an example where we just want to manipulate we want to create a new column, and we want that column to be I think it's the weight or the WT of MT cars. So there's a column WT. We want to take that column and we want to multiply it through by 100 just for the sake of an exercise. And that's the output we want. It's a column. And remember, a column is a vector. So it's one dimension. It's just a line of numbers or a line of values. And so like we talked about last week in class, before you set up your for loop, you want to create sort of an empty vessel to fill up with whatever your for loop is generating. And so in this case, we want to create an empty vector vessel. We just want a line of blank numbers that we want to fill in. So to do that, we can use the rep function, which I think is short for repeat. Maybe it's for replicate, but REP. And then the two arguments that go inside the repeat function are what value you would like to repeat, and then the number of times you would like to repeat it. So to make an empty vector, we can name it results, and we can then say, I want an empty vector called results, and I want to REP replicate it, so parentheses, and then NA, comma, and then we want this to be the length, and this is important, that also thinking about your output is how long is my output going to be? And if we want to manipulate a pre-existing column in empty cars, we can imagine that the output length of the column we want is also the same length of empty cars. So one row to get the length of empty cars is to use the function nrow. So again, we're replicating NA, comma, and the number of times we want our nrow, open parentheses, empty cars. And sort of getting into this habit, I think when you start nesting functions and working in sort of more complex coding, I think it's a good way to check your work to highlight ahead of time. So I want to just double check, is nrow of empty cars what I think it is? And I can highlight that nested function, and it gives me the value 32 in my console. So that is what I thought is the number of rows in empty cars. And so I want to repeat NA 32 times. We run this line of code, we get an object called results, and if we check it out, it just looks like 32 NAs, which is what we want. So now we have our empty vessel that we want to fill up with our for loop, and we want to create a new column. So we can set this up again for I in, but now instead of 1 through 10, we want it to be 1 through all of the rows that exist in empty cars. And we just looked and we know that that's 32. So you could hard code it in, say for I in 1 through 32. But in sort of soft coding fashion, it's really nice to say for I in 1 through nrow empty cars, so that in any event you added a new row or deleted a row, this for loop would always keep up with that. So for I in the number of 1 through 32, we can open curly brackets. And what we're doing here is now, where previously we had just sort of printed the results that we wanted, instead of printing, we want to store each one of these iterations or loops that the for loop runs through into a particular place in the results vector that we created. And we do that by calling on our now results empty vector and using our index brackets to call upon the I indexed value of results. And if we do sort of this highlight checking our work right now, if we call on what is the value of results square brackets I, it's actually just going to be 1 NA, and you would have no way of knowing this, but because we know that I equals 10, this is likely the 10th NA in the vector. And what we want to do is take every value of empty cars weight for every row. So again, empty cars $ WT index I. And let's say we want to multiply it through by 100. And so what we're doing is for every row value, we are multiplying it through and inserting it into that empty vector vessel. And we can go ahead and do that. And then check out our results vector, which is now filled with values that look very much like 100 times the empty cars $ weight column. So this is the general gist of how for loops work. We can get into some more details in class. And in one more video, I'm going to talk about map functions.